Hi, my name is Stefan Metzmacher. I'm working in the Samba team for more than 20 years and in SerNet for almost 20 years now. And today I would talk about the SMB witness service, which is used in Windows clusters, and I ported that also to Samba CTDB clusters. So the topics are basically a short explanation what the protocol is and how it works in the packet flow and so on, and interaction with the SMB protocol. Then the basic design of the RPCD witness daemon I wrote for Samba. Then some things Windows is doing strange when looking at the documentation, and some things were a bit unexpected, and I still need to clarify that with Microsoft and hope they may change some things. Then a short overview how to configure RPCD witness, and then an outlook of the net witness commands to administrate these things. So first, the protocol is a way for an SMB3 client to monitor a cluster and get notifications if network interfaces fail on a node, or complete node fails, or something like that, or there are planned downtimes and administrators want to load balance clients to other nodes in order to get nodes to zero clients and stop them or something like that. Yeah, the protocol itself is independent of SMB3. It's based on DCRPC over TCP. So it just uses the TCP, not the SMB named pipes for RPC. And it also uses GSS API integrity protection for Kerberos or NTLM SSP. So everything is signed, but not encrypted. But there are no confidential information there. So a basic flow of a client connecting to a witness service looks like this. As normal, the client starts with an SMB1 negotiate protocol request, then upgrades to SMB2, which is basically the same as SMB3. So in this case, it will be SMB3, but Wireshark still shows it as SMB2 because the PDUs are the same. Then there's a session setup, a tree connect to IPC dollar, and then a tree connect to an actual file share. And in the response of the tree connect, there are some flags which indicate some special behavior for clustered shares. The continuous availability is one of them, scale out and cluster. And basically, if continuous availability and cluster is set, then the client would try to start with the witness interaction. So basically, it creates a connection to the same IP address, which is the one with the 168 at the end, and asks that node about all IP addresses of all other nodes. And there's a flag, so the witness interface flag. We can see on the right side, this is a bit truncated, but we actually see the 166 there. And that means that's the first choice in order to connect to a different node in order to monitor the current node. So in the next step, we see the register X call for the net name, which is the same we see in the tree connect. And the IP address is the one which is also used in the tree connect. And with that, the node with the 166 monitors that IP address 168. And then the client issues the async notify request, and that gets a timeout every 120 seconds in order to detect failures early. So this is the normal case, no problem at all, and that goes on for hours and hours. Then assume a node fails or an IP address gets unavailable. Here we have the situation, the client is currently connected to the 167 IP address and registers with the 166 node. And then after some time, it gets a resource change message where it says resource unavailable for that IP address. And immediately the client reconnects to a different node. Here it does this for the 166, but it's basically random or based on DNS round robin or something like that. So there's nothing resource change message would tell the client to connect to a specific node. It just says this is no longer available. Try somewhere else. So after the reconnect, we see some delay of 5 seconds. And this is the first problem Windows clients have. Once they reconnect to a different server, they don't re-register the witness notification monitoring. And in order to force a re-registration, I came up with a hack to just schedule an async notify response with not found 5 seconds after the initial resource message. And that causes the client to try to unregister the old registration and restart from scratch, asking the current node for other witness interfaces, and then it comes up with the 168 node in order to register again and monitor the 166 node. Then the other case is where an administrator could move a client to a different node. There it says, please move to this specific node and reconnect to that one. So here we also have the same cluster again. The client is connected to 167 and ask 166 in order to monitor that. And then in the middle, we see the client move message that's triggered by an administrator and says, please connect to the node with 168. And the client does that. And there we still have this hack for the re-registration in order to let the client re-register the witness notification. So now the design of the RPCD witness daemon in Samba. We had ideas for that, I guess almost 10 years ago or even more. But the infrastructure wasn't there in order to have async requests and scalable IP TCP support for RPC in the source 3 in the file server parts of Samba. But luckily, Samuel Caballero and Volker Lennecke did some rewrites in the past, and that makes it possible to implement that easily. So we have isolated service binaries located under user libx Samba, and they start with RPCD underscore and then some name. And typically, we have the way that these are auto started on demand with the RPC start on demand helpers equals yes, which is the default. But with that, we only have the NCACN NP, the RPC over SMB named pipes support. But here we need also IP TCP support, and that means we need to start the Samba DC RPCD main daemon not on demand, but before all other services start. And that means we also have an endpoint mapper and also listen on a dynamic TCP port for the witness service. And with this infrastructure, we are also able to use async responses in an easy way, because in this situation, we don't do any file system calls into the kernel, so we don't need any impersonation for the user. So it doesn't matter if the async callbacks run as root. So in the past, we had various prototypes, one of myself and Gregor Beck, that was the first one. Then Günther Deschner and Jose Rivera did one. And I think David Disseldorp and Samuel Cabero built on top of that, but I'm not quite sure. But the problem is the interaction with CTDBD is very important and needed for this. And the first two prototypes don't have that at all. And the second one tried to implement way too much in CTDBD itself. So it was very complex in the design. And the good thing is that I found a very simple way to avoid that. We already have some event script hooks which run when the IP reallocation or recovery is finished. And we only needed to add an extra notification for C code, the CTDB server ID IP relocated notification. And with that, it was easy for the SMBD or the witness service to ask CTDB about notifications. And what we now do is, so we may have more than one instance of the RPCD witness service, so at least one on each node, and we have a pre-fork model, and that means that we may have multiple instances on each node, depending on how much clients we have. But the easy thing is that each one of these just load all IP addresses of the whole cluster at the start, and then wait for the IP reallocated events. And each time we get this, we reload the addresses again, and then compare the old and the new list, and then we know what changed and if we need to notify some clients about the change. So as I said before, this needs IP TCP support. So we need the RPC start on demand helpers equals no. And we also register each connection with CTDB in order to get TCLX also for the witness TCP connections. That means that when a node or an IP address moves from one node to the other, the clients get fast TCP resets. That's not critical, but it was easy enough to implement, so I did. So each register or register X with new clients results in a global registration. This is stored in a volatile database in CTDB, the RPCD witness registration TDB. And that's basically indexed by the RPC layer context policy handle UUID as a key, and in the content we also reference the PID and node number. We call that server ID in the content of the record, so that the net witness commands are able to list this by enumerating the database and also send specific administrative actions to the individual registrations, so that, for example, the client move command can work and so on. But I will have examples of that in later slides. So Windows is a bit strange in how it works. On the SMB3 or SMB2 tree connect response, there are various flags which can be returned. The continuous availability, scale out, cluster, and asymmetric flags. And according to the documentation, the cluster capability flag would be the only one that should be needed in order to let the client use the witness registration. But Windows clients require also the continuous availability flag to be there. So only if they are both there, the clients will do the witness registration. The scale out bit, I don't think that has much impact at all for the client. Maybe one or two things. But the thing is that with CTDB, all shares are scale out by definition. So we always return that. And basically that indicates to the client that there's more than one node active at a time. The continuous availability flag indicates that the share is more or less always online. So if the current node fails, it can connect to another one, either in a failover cluster on Windows or a scale-out cluster with active support. But the thing is that for the client, that indicates faster reconnects, but it also means to the clients to request persistent handles on the share. So each open would request the persistent handles even if the server doesn't announce the global capability for persistent handles. And that means that against Samba, each open generates a warning in the client's event log. And that's maybe not what we want, and maybe Microsoft can change that to be maybe just a warning once per tree connect or so, if it finds that condition. Then there's another flag, the asymmetric flag. This is not so important for CTDB clusters, but on Windows, there might be the case that there's one disk owner. So one node owns a disk and serves the file system there, and all other nodes basically act as proxy. So it doesn't matter to which node a client connects, but the best performance would be when it connects to the disk owner. So this is an indication for the client that it uses a separate set of connections just for that share. So if you have that on two shares, could be that the client connect to node A for share A and to node B for share B. and the connections are completely independent and have their own witnessed registrations, their own client GUID, and their own multi-channel setup, and so on. So, yeah, and so because of these characteristics, it might be useful in some situations with CTDB2 in order to get better bandwidth and performance when connecting to multiple nodes for different shares. But we don't have this concept of a disk owner and proxy support. And if that's there, in addition to the registration with the null share name, the client also does registration with a share name given to the register X command, which is results in a second registration. And there's also a share move command similar to the client move command, where you can move client connections for specific shares to other nodes. So as said before, when I showed the captures, when the async notify response returns the resource change, client move, share move, or so on, a Windows client won't immediately re-register the new SMB connection with a witness service on a different node. And for that, I created the trick with the not found after 5 seconds. And that reliably caused the Windows client to register. And it makes it much easier if you look at the net witness list command. I will show that later, and see which IP and so on a client is really using, and not to see this date from minutes ago or even hours ago. So in order to configure this, I use this very simple smb.conf setup. So the RPC start on demand helpers equals no is there. And then because we don't want to flood the Windows client logs, we have the SMB3 share cap continuous availability to no by default. So if someone wants to experiment with that, it can be used there. It could also be in the share section below in order to have it just for a single share or so. Yes, and in order to let CTDB manage the Samba RPCD startup, we added a 47 Samba DC RPC script, which can be enabled with CTDB event script, enable legacy, and so on. And that means we require RPC start on demand helpers equals no, and then CTDB will transparently start up the service before starting WinBind and SMBD. Then we have the net witness commands in order to give an administrator an overview about the registered clients and so on. Then we have the net witness client move that is able to generate client move notifications to be sent to the client for a given registration. You can provide the IP address or the node number where the client should move. The same for the net share move command, but it obviously only works if you have used the asymmetric option and clients are actually register with a share name in addition. Then we have the netwitness force unregister command. And that's more or less, in order to let clients register itself mainly in the same way. I do it after the 5 seconds I mentioned earlier. This was just easy for debugging and so on. And we also have the net witness force response, where you can construct a response based on a JSON input, but that's really mostly for testing and having a way to construct any possible response and to watch the reaction of a Windows client for that. So the example net witness list, you can just run it without any arguments, and you will have one line per registration and just see the basic options there. The registration UUID, the net name, optionally the share name, the IP address that's registered, and the client computer name. And with the --JSON option, you can see much more. Here you see that you can also limit the displayed registrations. There we have the UUID given, but there are also options to limit by client computer name or by IP address or some other things. You just try to read the main page or use netwitness list --help. It will explain all this. One important thing to mention here is that we have the auth section there, and there you see the account name that is the client's machine account. So even if the client mounts the share as user administrator or whatever, the actual witness registration is done with the machine account, and that has quite some impact depending on how ID mapping works and so on. Then examples with witness client move. The first example is we move a client based on the registration and say, please move to node 0. Node 0 is the 166. And it puts out the old registration, and then we call net witness list in order to see that the client actually moved to the other node. For testing, I also have this --witness apply to all option that makes it easy without copying the UUIDs and so on each time you want to rerun the command. But obviously that is only useful if you just have one registration or just a few. If you do that with hundreds of clients, it won't be fun. Yes, so with Samba 4.20.0, all changes are included. And as said before, I will try to ask Microsoft to avoid flooding the client event log if the continuous availability is there, but no persistent handle support. So actually the client logic works fine. It falls back to just durable handles, but it always logs the situation, and that might be unwanted. So that was my talk. Are there any questions? I thought there were some questions in the chat, but I think Volker answered most of them, if I see this correct.
That was just about basics, DCRPCT.
Yeah.
Stefan, I have a question. Other than sending that other error code, like not found, if you would just not send a reply at all, would that change the behavior and let the client maybe start re-registering the witness notification?
What do you mean by don't sending a response at all?
You said that you use this kind of undocumented behavior where you basically send a specific error code back to the client to let the client cause to issue a re-registration. And instead of not replying at all for a while, would that have an impact on the client behavior?
Yes, so we typically response after 120 seconds, so the timeout the client specified, and then we reply with timeout, and then the client starts over. So it doesn't really matter which error code we send. We could also send a response with status OK, but no message. But I think with the not found, it's so basically if there's a timeout and the registration expires, you would also get the not found error. So the client already has to react on that, and yeah, that made me use this.
Okay, so it's just more explicit and more visible.
Yeah, and
okay.
it makes it easier to see in captures and so on.
All right, thanks.
Okay, one more question for myself here. So you mentioned a few times that we have the we are responding for shares to be continuously available now, but without implementing persistent file handlers. So is there a path for implementing persistent handlers in Samba?
Ralph has some prototype somewhere, but yeah, that's
great.
But it's far away. So
yeah, it's still far away. I mean, we discussed this many years ago, where the gap is essentially how to persist the state for the open file handles that we store in volatile databases right now. So we need some kind of intermediate database type in CTDB for this. Was the idea back a couple of years ago?
Michael,
yeah,
I've talked to Ralph about this. The design is there, the funding is not.
Right. Okay.
You want to fund
the usual problem.
If you want to fund it, I think a lot of people would be very happy.
True. Including me, but I'm not in the position to fund, I'm afraid.
Well, talk to the people who are.
Yeah, we can dig. Okay, fine. Anyway, great stuff. I'm really happy and glad to see this landed in Samba upstream now. Kudos to Metz and everybody who helped do this. And I'm also glad it kind of didn't completely throw away the prior artwork from Günther, Jose, and Samuel. So that's great. It's building upon that, if I understood correctly.
No, not really. I took the ideas and so on, but in the end, there was not much left. But actually, it was much easier than I thought.
Oh, that's good.
The basic surprise was that we do have async RPC server, right? In source 3 as well.
Yeah, that too, but also the actual code is really simple.
Good. Anyway, fantastic.
Thank you.